Example 4, from a given point on the ground, the angle of elevation to the top of a tree is 36.7 degrees. From a second point 50 feet back, the angle of elevation to the top of the tree is 22.2 degrees. Find the height of the tree. All right, trying to find the height of the tree. The key to this problem is noticing the two different triangles. Okay, there's the height of the tree. But you should see this right triangle right here. Okay? And if I want to know the height of the tree, this triangle is set up for me to look at the tangent ratio. So I would say something like tangent 36.7 degrees equals opposite side h over adjacent side x. Okay. Now the problem with this equation is I've got two variables in it, and I can't do much with one equation with two variables in it. If you've got two variables, you're going to need a second equation. All right, you would have to have a system of two equations with two variables if you're going to solve. However many variables you need, you're going to need that many equations. So you should be able to see something out of the bigger triangle. Okay, so if you look at this big triangle right here, you can make kind of the same statement and use a tangent again. Tangent 22.2 degrees equals opposite side is still h over the adjacent side. Now notice that that big long side right there is not 50. It's 50 more than x. And so you could say that bottom side is x plus 50. Okay? So the key here is you've got two equations with two variables. You're going to have to solve a system of equations. Now, yeah, I know you've probably never solved a system of equations with trig in it before, but it's really not much different than any other algebra problem. What you might consider doing is isolating the h in each of these two equations. So we've done problems like this where we've had to cross multiply. H is going to equal x times tangent 36.7 degrees here. And if you did the same thing with the blue one, h is going to equal x plus 50 times tangent 22.2 degrees. Okay. So what we can do is, since both of these two things are equal to h, they're both equal to the same thing, so then they must be equal to each other. So you would just set those two things equal to each other. Now, really, at any point in this problem, you could have typed in tangent 36.7 and tangent 22.2. I've kind of held off on it, but let's go ahead and do that now. Tangent 36.7 and tangent 22.2. You're going to have those numbers, so just replace the tangent statement with those decimal approximations. 0.7453, so I've got 0.7453x. I like rounding off to 4 decimals, so you can do more. I wouldn't do less, though. And tangent 22.2 was 0.4081. So 0.4081. And really, all we're doing is solving this equation at this point. Now, also, I've approximated, so technically we're not equal. We're approximately equal, so keep that in mind. We have rounded off at this point. So just do your algebra. We're going to distribute. Exact number times 50, and you've got about 20.4046. I would subtract this number over. .3372. and then divide. Keeping in mind we are only approximately. So we've got about 60.5. Bless you. Okay, x equals 60.5 feet. That's not the answer, though. Okay, right? That's not the answer because the question wanted to know the height of the tree. So we're just going to have to do another trig function. So I would just look back at this red triangle again. That's probably the easiest thing to do. Not the only thing, but the easiest, I think. And we knew that tangent 36.7 degrees was equal to opposite side h over this number x. Or I guess what we could have done was just plug that x in for right there, because you're going to have h equals 60.5 times tangent 36.7. About 45.1 feet. Notice it says round to the nearest foot. So let's go ahead and round to the nearest foot and call that 45 feet. The height of that tree is 45 feet.